We are driven by purpose, and our purpose is to pioneer solutions to wicked problems that are not easily answered, that don't have a good answer, that require you to take risks, but most importantly, they require you to bring convergence, and not just convergence of disciplines, but convergence of different sectors. And that might be policy, that might be economics, that might be community, that might be particular kind of technology. All of the above, it might be behavior of people, etc., to come together to solve those different problems. So, as our title of our institute says, you need to have integration of ideas, integration of things, integration of all of that together. Innovation. We are committed to bringing about economic development, obviously locally, but also for our state and then beyond. And we want to find solutions that can scale. So we talk about convergence, integration, innovation, and economic development, and moving to be at scale. So what we might pilot here, we start with the thought process that how would this solution actually get scale? And that means we are driven by deployment. So that we believe if we can find a deployable solution, we'll be able to find impact. So as we think about this bold vision, and we want to be the preeminent leaders in it, we want to learn from our colleagues here locally, but nationally and internationally, and have experts come in, join us in this vision, guide us in this vision, and perhaps inspire us with what they have already done. And so it is my pleasure to introduce to you all Dr. Vassigh. She's a professor of architecture and director of robotics and digital fabrication lab at Florida International University. Some of you know that I was at FIU before I came here, and I knew Shaheen over there. What you will not see in her CV, which has got a bunch of many grants and many other papers, all of that is that several years ago at FIU, they opened up there was this Shakespeare's whatever centenary thing was happening, right? And so, and as part of that celebration of that, at the university, computer science and the Department of English, Shaheen and their department got together where there was an iPad was put together. And so Shaheen worked very closely with the computer science people and the English department where this immersive space was created. And in that immersive space was England at the time of Shakespeare. I was the interim dean at that time of the college. And so this was an amazing, it was exemplary of bringing humanities, architecture, design, engineering, computing, all coming together to really celebrate and wear something in this. I hope that IPA is still going on and it is still coming and being put together for a long time. So I think perhaps that might have been the first introduction to you really, is through that. And then I got to know her with this really interesting viewpoint of merging different ideas and then the robotics work that she extended and built more into. And so this is the kind of person we want to hear and learn from and see what is the vision that she has had for decades and decades, that and the new ways in which she thinks about things. And more that I think that's the most important part of how you think about it. She's multiple grant funding, other grant funding, and also education so strongly tied. I note that you have one federal grant, the comprehensive approach to teaching structures, building literacy, the integration of building technology and design in architectural education. So how you do a new kind of new ways of educational pedagogy, how you have brought all these different approaches together. By the way, she's a civil engineer. So, so it is really, really a pleasure to have you be here. We are looking forward to having you go to IPR building at the coming fall. And actually getting your ready to say how do we get these spaces to the right space. So happy welcome, Penny.
Well, thank you for having me here. Thank you for that amazing introduction. I hope I can live up to the expectation that was set. So the title of my talk is Enhancing Educational Landscapes, Harnessing AI for Immersive and Adaptive Learning Environments. So this is actually one, if I was going to explain myself, that is one direction that has been constant throughout I've done a lot of jumping around, but I've been interested in improving education using technology, using whatever advances that come. So this is actually a related idea and a project that I'm going to show you to this. Oh, insert. I can do it by hand. Yeah. Okay. Just working and not. It's okay. All right, but before I start, I'd like to actually talk a little bit about this idea of adaptive learning environments, which have been around for a very, very long time, beginning in 1920s. That, the early concepts of adaptive learning environments basically was started or was initiated by educational theorists like John Dewey, who introduced the idea of using technology in education and using technology for personalization of the student experiences. Later on, actually, in 1960s and forward, the intelligent tutoring system enabled actually some further adaptation of these technologies and learning environments that actually would change based on the student responses. As early as 1990s, AI and machine learning started to kind of overlap with this adaptive learning environments, which they were very simple, but introduction of AI made these systems a lot stronger and began integrating with the learning management system. That's something that like a lot of faculty use today. So finally, in the past decade, maybe a little bit more, the rise of AI platform have changed the adaptive learning systems to adaptive intelligent learning system by embedding AI in them and using big data and big data analytics for providing like scalable and personalized learning experiences. So this has the promise of more inclusivity because people come to education from different backgrounds, and just trying to find a level ground is very difficult unless you can kind of treat each student based on their own strength and weaknesses. So the adaptive learning systems, or AILS, built on several important data sets, key data sets. One is learner's preference and background. So it's kind of understanding where the learning is coming. So for example, in interdisciplinary education, people come from different backgrounds. What is their interest? And then the learner's performance. So as soon as they enter this environment, how do they perform? So if you can measure the performance along the way, as much as you can, then that can guide you in order to kind of make that customization. And the learner's interaction. So if you are in an immersive environment, learning interaction is a really important part of learning. So with these, type of data sets, you can do a customized curriculum, which basically provides the curriculum exactly based on your strengths and weaknesses, and then provide feedback when you need it. So this is actually a great promise of how future education would be, hopefully, or should be. So these are achieved by implementation of machine learning, natural language processing. These are two systems that two areas that we are using in the example project that I'm going to show you and how we are doing it. But also Computer vision is another thing that is like kind of a lot of other projects are incorporating it. So one thing that is basically at the beginning, at its infancy of growing, is the integration of this adaptive intelligent learning system with virtual reality or with extended reality, a series of AR and VR. So this actually integration has promise of truly transformative way of looking at how we educate. So there are different ways that all of us as faculty know that contextualization is really important. That, I used to teach structures, and when students don't see the context, they have no clue what they're doing. They're just dealing with the beam. They do not know where it's coming from. They do not know where it's going to. So it's like a lot of engineering education is, lacks contextualization. So this integration allows us to provide context, and they can provide interactivity too, which is already like many years have been written about, that it will provide, access, or it will enable experimentation and exploration of, of the learning. So you can actually be a part of the scene rather than just kind of receiving. These are all like things that have been like debated and proven in many papers. And then another thing that has been actually very connected to VR is basically embodiment. So there are some learning scientists that are actually closely following that. And I'm lucky to be working with one of them, that actually they're looking how embodiment, or like physical activity while you're learning or engaging bodily senses and motor actions while interacting with the learning content can enhance your learning, or what is it, how does it do it? So that's actually another really interesting area, which is emerging again in the past 10 years in a much more significant way. And the fourth one is that, yes, together AI and AILS can provide personalized immersive education and various feedbacks and various pathways. So your path of learning is different from my path. I would take a curriculum that is tailored to me, and you're different from me. So based on these ideas, being inspired by these ideas and what is happening in this area, in 2002, I got together with a bunch of my colleagues, very interdisciplinary group, we have like and then we started writing a proposal for NSF. That is actually, we have faculty from cinematic arts, from computer science, we have one expert in natural language processing. We have a learning scientist from UCI who is just absolutely fantastic. And then we have actually Shuqing from FIU, who is now at UMKC. He has his data center. So working together, we wrote this proposal and we got funded from 2022 to 2025. And we are like in the thick of the project. So hopefully I can give you a little bit of understanding of what it takes and where we are with this. So the idea actually of the project was to research and develop an immersive, interactive, and personalized platform for training 3 different groups of students, or 3 different sets of people who are interested in learning robotics, learning industrial robotics. So that would be architecture students, construction, and engineering students who are like interested in this. Okay, the initial research was actually for us to understand how do we kind of start this. So starting was to look at the curriculum and think about the curriculum. Do we, like we have to write a robotics curriculum? Is that exactly like the same way that you're doing, that you're teaching robotics? Is it different? How different it is? How different the lessons should be if you're putting it in, in VR and then you're putting it in AILS? Then the VR development for key considerations should be addressed. when you are actually developing these together. So ALS, there's a lot of written about it. AR, there's a lot written about it. But when you bring these two different technologies, so what is the intersection and what is specific that you have to look at? And then the data collection was an important issue. Again, this is like we did a lot of research through literature, through looking at what other people have done in a smaller scale project, that what type of data are important to take from from the students. What are we going to collect? And then what are the key challenges if you're collecting different type of data? So our research in the area of curriculum brought us to these like bullet points, that basically the way that we should think about developing the curriculum is as micro units. We cannot have like a long curriculum that keeps building on on lesson 1, then lesson 2, as so we had to make them very independent, because if we were going to provide an alternative path and the system is taking you're looking at lesson 1 module 1, but then you're doing really well and you have to go to lesson 2 module 3, we could the system could put them together, so can pick up and reconfigure your path of like what you take first. So as much as possible, which is really challenging, you cannot write completely independent units, but as much as we could, we had to make these as very small lessons, so the small lessons can be reconfigured much better than bigger lessons. Then we sat out and we got to the conclusion that we cannot really teach in this environment. So what we want tasks that students do in this environment. So it's like basically task or activity driven lessons. Then we had to think about designing performance measuring events that we can't constantly, we're constantly collecting data, but some of the data that we were collecting is just doesn't make sense. So we had stations that we would give students a specific task and we would collect information from that. So after a lot of research, we settled on 6 modules, basically like module 1, robotic kinematic change, module 2, work envelope and robot error. So basically these are like the standard things you have to know on how to operate a robot prior to get to any program. And then, we figured out midway that we have to have a different way of delivering these other than the AR. Because some people, like if you're saying it's personalized, some people don't even want to wear the goggles. Like how personalized is this if I cannot, if I'm not interested in that? So we did a lot of multimedia lessons with animations. And then again, midway, we realized, wow, this is really going to help us with, with our tasks. So what we do now is prior to enter to the VR environment to conduct the task, you're told what to do. And then, you perform the task and then you're asking you questions. So the students actually can learn the basics. So the basic concepts that, the things that you should know, you will learn in the multimedia before you come to this environment, which is very task driven. Okay, I have taken like screenshots of like very, a very small part of some of these modules that we had to develop, and everything. We have like hundreds and hundreds of spreadsheets like this. So I'm looking at one module, like let's, as an example is acceleration. So we are teaching robotics acceleration in module 4. So we have actually written this for instructional prompts. So first, we had to hard code everything. So these are the prompts that would come based on, hard coded information. So welcome to this, and in this module, what you learned, there's a little bit of introduction. Then, the name of the task is ball balancing. So we tried to put a little bit of game in there. So in order to understand, how fast or how slow you have to operate the machine, you did this, this exercises. So, like let's say move the robot from position A to B and C. These are all the audio. So that the code that is in there is just the audio that is connected, that the code will call with the audio. And then basically asking them to continue making squares with the paddle in the air till the ball rests on mark X, and they have the goggles on and they're just doing that in the air. They really do not have anything in front of them. So then, we made these stations we call think aloud exercises. So once you have done a few tasks and you kind of got the gist of it, then we ask the question. So this is one question. We ask a series of questions. So explain this task. Explain in this task how the weight of the balls impacted the way you accelerated or decelerated the robot between the positions. So that is where we are collecting a lot of data. They're starting to say stuff and we are recording it. We're recording it first. We recorded with recorder, and now it's like through the system, everything gets recorded. So we have the information about their performance. They're trying to say what they did. And the VR development, we kind of settled on Unity 3D game engine. There's Unreal, which was actually, we didn't have any expertise. Most of the computer science students did Unity 3D FIU. So we went with that. And these are like the several tasks that we had to do. So we had to do a digital twin of the robot, and we made it agnostic. So it's not like, first we went with Kuka robots, but then we realized we shouldn't go there. So we did a digital twin. Then we developed a 3D model of a robotic lab. Of course, we had architecture students and they wanted to do this futuristic thing. I'll show you in a minute. So it was their vision of like what, how we should teach robotics, in what type of environment it should be. And we did the 3D assets. We had, we developed the user interface, which still like correcting, and it's still not there. User experience is the same way, we're still working on it. And then creating telemetry hooks inside the VR. So when I start a task, there is, it captures my start time, it captures my end time, it captures how many times I try. So there's a whole bunch of information that we collect from the telemetry side, from the VR side. So we have the audio information and we have this information in here. Initially, we wanted to do gaze, gaze information, but it just became so complicated, everything, that we kind of let go of that. But that's something that actually is in the back burner somehow, someday we'll get there. And then also a navigational tutorial that we developed. So I have a little movie of this, of the environment that we developed.
Welcome to the Robotics Academy training facility. This is an immersive environment that uses virtual reality to teach users the fundamentals of industrial robotic arms. In our facility, you will virtually interact with several of our manipulators to learn robotic programming, safety, and end-of-arm tool operation. There are many types of robots, but for safety purpose, we can generalize into two categories. Industrial robots are meant to be used in industrial settings where there is no contact with humans and multiple layers of safety built between humans and the robot. Collaborative robots, on the other hand, are designed to work alongside people.
It's good. Okay.
I will show you the 6 axes of this manipulator and the axis in which they rotate. Here is axis 1. Axis 2.
So this is more of demonstration at the beginning before they really get to
Axis
do the
3. Axis 4. Axis 5. Axis 6. Axis 6 is the interface axis, and where you will attach any end effectors. Let's look at the command panel and identify the main elements. The first button to take note of is the emergency stop button. When this button is pressed, the robot is unable to execute any motion commands. In order to use the robot, you will need to depress or disengage the e-stop. Next, notice the buttons underneath the emergency stop in the command panel. These buttons display information on the robot or program status and can be engaged to alter the current operation functions. Now that you are familiar with the basic robot anatomy and general safety, We will learn how to move the robot manually. This process is referred to as jogging. You can see a ghosted silhouette of the robot in front of you. This is your target. You will need to manipulate the robot's position using the command pendant to reach the target position. Here is an example of how this can be successfully completed.
The student put the music on the background too, so. So this is actually the biometric data that we were collecting at the beginning, even that it just became way too overwhelming. Okay. Next. Okay, so that was the AR that we were traveling with, and we went through the curriculum. Now it is, it's the effort for developing the actual AILS. So most of the literature we read, and they were saying that some say you have to develop these models, a model of a student, sorry, a learner model, a model of the curriculum, and we will go through them. But we looked at learner model, and basically, what does that mean? We realized, okay, basically we are collecting data. What are the data? There's a profile data that is basically about demographics and background. And then performance data that basically we are looking at screen test, and we are questioning during the activities, and then think aloud stations. Those are all the data that actually will go to our learner model. Then we also have telemetry data from the VR that's in action generated while engaging with the system. And these are like things, time to make a decision, how long the student took to make a decision. Then did they complete a task or they did not complete a task? How many attempts they had, how many errors they had, and what type of errors they got. So then we also had to think about a domain model. We had the curriculum, then we had to have lessons and learning objectives. And the most important thing was having basic concepts. So every lesson had to have clear designation of what is the basic concept, because we had to compare, the performance. Is that concept, is that word in there or not? So that was an alternative paths and tasks. So we had to develop, we are still developing them. Okay, you take module 1, module 2. In module 2, you're really, really advancing. So we are laterally, moving you, out of the direct curriculum, give you different tasks. And the tasks go more difficult and more difficult. If you are not performing that well, your alternative tasks will take you horizontally in a different direction, basically the tasks that you can handle. And hopefully that would be the remedial work. And then instructional model, like what is the instructional model like, the rubrics, and the rules for scoring. So first we were like really kind of set in like having a grade, like, okay, what is your grade in here? And then the learning scientist was completely against grading and all of that. So basically what we are doing now, we're looking at a level. So you're at this level, and I'll show you, how is that being decided. Okay, the data collection. So we started like as soon as, the grant we had, but we had nothing else. We just had, we didn't have any VR environment. So we, in the initial step, we said, okay, we're going to do a control group of students like standard, and then compare it with experimental group. But it didn't work because there was nothing to compare. They're so different things. If you have a person, an instructor who's teaching you, is a completely different ball game than you have the VR. So we used we started with the control group. We just did the traditional curriculum with robotics, which is mostly either like, either manual. So you get the robot manual and you learn from that, or there's not a lot, that is well thought in that area. Then, we collected video and speech and profile data. That was just a form they come and they do. Then, when we had the VR environment developed with the 6 module, we did the experimental group. So the good thing with the control group, we didn't use to compare, but we learned so much about how to do the VR, because if we were just stumbling at everything that we were teaching, this kind of students' questions, the kind of teacher answering them, all of them, like, was a lot of data that helped us to do like, a better VR, in the first shot. So we looked at experimental groups, VR curriculum. We were able to do telemetry data now, just constantly getting information about what the student is doing with the system. And then we also did video speech and also did the profile data from them. Okay, so we divided the team, the faculty team to a natural language processing team and a machine learning team and a curriculum. I was like, running the curriculum team because I do not know any of those areas. But basically what the natural language processing team was involved in, it's like this 3 or 4 people, one doctoral students, some graduate students, and our faculty from FIU. So first was just, to take all the speech data that we have recorded, you translate it to text. Then, we realized that in order for us to make sense of this data, we have to really look at it first, like human, a lot of work. So we asked the students to start rating and looking at labeling them, and nobody knew what to do. So we basically figured out, oh, we have to do a code book. So we did a code book for labeling. I have a snapshot of that I can show you. Then we had to take tagging of core concepts. So we started like manual with people, like students, like we had data that went like, 3 students who learned about the project. These had, their student assistants. They would look at the data and then rank them or label them, the same. And we look at the differences. So it was a lot of redundancy in there. Then speech data based on concepts, they were labeled. And then, the training with NLP for speech data, that's the next step. Then where we are not there yet, it's predicting student performance. So once our model is completely figured out, then, we're gonna get some prediction of what the student performance is going to be as well. So we can actually anticipate, the path for the student. And then, the last step of this, which we are working on right now as well, is the text and audio feedback. So the system, so if you make a mistake, if you get a certain error, the system is coming and will tell you, oh, you made this error, why don't you go to this lesson, or to give you some feedback, some constructive feedback. So for our code book, again, I'm just looking at this acceleration module so we can kind of maybe get something out of this. So the key concept was that the more weight the robot is holding, the slower it should accelerate and decelerate. Then we gave like an example of that to the person who's coding, a heavy tool mounted, I'm not going to read it, but there was an example of what would make you think that the key concept is there, and then what are the fundamental elements of acceleration. We had to write this for every single module, every single task, subtask. So of doing it, then this is a snapshot of what the students, the assistants were helping us with. So let's say the student is saying, I can't, the recording saying, I can't figure out why it's so hard to control this ball. It's a ball balancing. So I was able to do it before. So it's labeled as L1, and that you have no awareness because you have no clue why you did it before. And then basically the explanation is that your labeling is based on this explanation. The utterance exhibits the lack of understanding, or there is a misconception or misunderstanding of the concepts that we kind of tag. Mass and weight and its impact on determining the speed at which the robot should be jogged. So the student doesn't. So that's how all the data is being tagged. Okay, so this was basically the job of the the natural language processing group, and then we have the machine learning group. That actually looking at the telemetry events, they're looking how many errors. So there are 2 separate groups. They're looking at very different type of data sets. And then what is the haptic engagement? And then basically what they're doing, they're training interaction data with machine learning, and then some prediction of the student standing or performance in that. This is actually a snapshot of our machine learning code. So this is basically showing codebook. This is showing every location, the location of the ball as at any second. So you can see where the ball is as the student is doing this. So we can actually make some predictions. Really something really interesting. This guy who's doing our Seth Corrigan, Dr. Corrigan from UCI is really interested in the interaction. So we are developing these amazing graphs of students, like how a novice is doing this, somebody who doesn't know, has never touched a robot comes and how did they try to balance the ball in VR, and then somebody who's an expert and compares their graphs, and then how we can learn from the novice in order to improve the way we are presenting the lessons. And this is actually our workflow. So after we have the speech, which is feeding the natural language processing, speech data. Then on the other side, we have telemetry data, we have the machine learning model, and all of them come to this system that we haven't merged, that we are going to kind of merge these two different data sets. And then out of that, we're gonna have let's say one level for where the student is at, and then from there, what the decision is. So how are we gonna send them to the next task? So in closing, basically there are many challenges. Our team has had a lot of challenges. First, because a lot of things that we didn't know. So this really needs true interdisciplinary collaboration. So if I do not sit, and I'm not computer science, if I do not sit when the machine learning group and natural language group are talking together, I cannot lead the project. So it is really, and it's the same for everyone. All of us have to be there all the time in all of our meetings. Data collection is very time consuming. So in the initial grant, I wrote we're going to do 100 students, and we've been struggling. Now we are up to 40 students, and it's going very slow. We have to bring every student, put this on, we have the setting, we have to have 4 TAs, just looking, making sure this works and that works. So it's very challenging. And then also the technological infrastructure is not completely there yet. Adoption of VR requires high-end devices. So we're thinking, okay, once hopefully by the time we have some outcome, this is output, it will be, it's a research grant, but I'm really hoping that I'll have something tangible that we can share. Hopefully by then it will be okay. And then the internet connection is really important too. So if it's coming on out, then this thing is and also the cost of content development. Like now that we did this content development, it was a lot of people who have to know a lot of things about different things. And then software licensing, they're all the issues that are challenges. But affordances, I think the integration of these AILS and VR really, once it's figured out and it's comfortable, it will really change the way people learn, because you can come and you can interact with everything. I was just talking to you about trying to do the same thing for teaching structures to architecture students. Imagine a student is in the environment rather than sitting with the triangular the beams with triangles at the end, and the reactions that are actually looking at the beam, they're touching it, they can separate it from the rest of the structure. So this is the possibilities, and I mean that possibility has been there before, but now if you can send them to the right place, that's amazing. So I think the other thing is that research and refinement of these technologies are really crucial for for advancing how we learn and how we teach. So that's that. Thank you. Yes, question.
I'm just curious. I mean, obviously you're only halfway through this, so still a lot to learn, but how generalizable will this be? You mentioned a team that has to build just this simple, not simple, but very specific course. Do you have to replicate that for every type of course, or will there be some point where it's more point play?
So we just recap that for online.
Oh, yes.
Okay, I think the question was how generalizable these ideas or these technologies are. I think they're much more scalable than generalizable. So you can scale, you can develop something that you can put online, and everybody who has access to VR can down. That's actually our plan from a website. You access, and then you don't need a robot. You don't. So a lot of things. But as far as I think our biggest setback has been to understand the process. So what do we do first? So it took us a year. We were like frozen, and we were looking at a lot of different projects that have done like very small scale of this. If you want to do it at a scale that is large scale, I think that process is really difficult to capture. So if we know that, okay, all we have to do is to get this type of data, the process would have been much more easier. So I think like the papers that come out of like efforts like ours and many others, once you know, and I think the technology is improving in a significant way, like, probably asset generation, which we have to have a student model, this and that. That's resolved in a couple of years with generative AI. Go say, okay, give me a wand, give me a tray, like whatever you want. So there's no effort. So if you're teaching physics, you can create your assets like that. It's the workflow. I think for us was the time consuming, and then really not knowing was the workflow of this. But I think it has the potential to be. Let's say if you do it for chemistry, like you do it for chemistry once, and it could be improved for years. And nursing, you wanna, or whatever, I think it's really applicable to many different areas.
I think the mission is to change. It might be an aspect question. In your opinion, how do you think this will change the traditional structure? This will modify how we learn and how we teach. But then evaluation, how to validate that. Do you think this will kind of change the way how these are?
I think so the question is, how will it change the future of higher education? How it impacts the way we teach right now. I think it will change significantly. I don't think in a sense that we will let go of this, of this setting, but I think it will allow people to work a lot more independent work that is really not necessary to be in a classroom for, but keep that area, that gathering for much more important kind of ideas about the same thing. So we were just talking about teaching structures. I used to teach a long time ago. I was thinking that me standing and lecturing is really useless. It was useless. So basically I did away, and then, it was just the lab sessions that the students were doing it. So that is like where you can actually have more impact of engaging students in other activities. And this also, I think one of the things that this does is good for things that are not really accessible. Robots are expensive. Not a lot of people have robots. So if you want to learn one of them, it's easy for you. It's safe to put the goggles and be prepared. So when you touch the robot, you're not starting from zero and some guy standing next to you and charging you per hour. So you're at least you're on the way. So I don't think it will replace, but it will change. We're changing as technology comes. We're still here. Yes. I think for institutions, yes. What are the barriers for adoption? I think basically content development is one barrier that that I spoke about, that it's not easy to develop the content. But once you have that that's done. You can always kind of update it and make it better, improve it, change it. But that initial step, which is usually done through a grant. And then most grants are not for development, they're for research. But once we get there, then I think that's the barrier. From my perspective.
Going back to, sorry, Jeff. Thanks for. the
He's
great
next.
talk. So I wanted to talk a little bit about the challenges that you have there. This is kind of related to that as well. So in terms of the translation, we talked about Unity and Unreal. And I know there's that whole debacle that was going on with the Unity softwares, like charging fees and stuff like that. So in terms of the actual translation into a real-time setting, for instance, we're actually going to have it implemented in lab, right? So does it actually change quite a bit if you're using one VR system versus the other, like this versus?
Yes,
Yep,
yes,
so
that's actually one barrier. We started using, we changed to Oculus 3. Is that like the new one? And it took us 2 weeks, but 2 weeks is nothing compared to to the 2 years that I put in this. So it's not that difficult. So you can move from one system to the other system. That's not that bad. And then you can make exe files for whatever, so this is for this type of goggle, this is for this type of goggle. So we hope we're gonna do that. Yes. Yes.
So what robot or robots are you actually using? That you mentioned the cookpit, and I actually saw 2 other different versions. In
Yes.
The video you played. I'm curious what brand or models you.
So we kind of at the beginning, if now we are using XR, our digital twin is of XR, but we started with KUKA because we knew KUKA, and then the technology is moving, and then we got URs, and we were all excited. But I think the digital twin is of an XR.
Another question too, with your ball studies of different size and weights, are you using an adaptable single gripper, or are you using some sort of multi-stage gripper?
No, we are not using a gripper. So we 3D printed actually no, that was for the experimental. For the control group, we had like a 3D printed tray, and then the student will put that and then manipulate the robot. For this, we are not, they're not using, they have the same tray in a model. Yes. So there's no gripper. Yes.
Are there any plans to integrate these as part of the university? Because I understand this is kind of like the brand aspects of it, right?
Yes.
Are there plans to make it part of the curriculum?
Okay, so the question is if there's a plan to make this a part of the curriculum. So right now, this is very fundamental. Yes, so we are thinking it's for training workforce, or if you're a student, you want to get some assets on your side. We do micro credentialing. I don't know if you have it here. So like one way that we test this is by offering a micro credential. Student come, they're with us for 7 weeks. They do this, they get a badge. So this is not, because I think a robotic curriculum is much more sophisticated than that. And, it's a lot of programming. It's a computer science, but, this is just to get you ready to operate the robot. And for example, if you're in manufacturing, if it's workforce development, that is basically the most suited. Yes.
Just to jump on those 2 comments. Just so I'm sure, like you're basically making very general intro to robotic, using a robotic arm,
Yeah.
not a specific.
Yes.
inter-
No, because that would be,
Yeah.
we started with that, but that would be really, that wasn't working because everybody's using it different. We actually went with KUKA, we tried to get KUKA on board to work with us. That didn't work. So we were going to be a part of their academy at the beginning, but that didn't work. And then we realized, okay, people use different robots and they're just new ones coming much better. So we said, we'll make it agnostic. This project has a long way to go till it's like what we want it to be. But we are excited about it. It's a good project. I'm looking to learn from others, but I think we have pushed it to the next level. So it's just, we are the good place, but not where we want to be. Definitely.
I have a question. All of this is inside the lab setting right now, the things that they're doing or practicing and things, you think that some of this could be taken out to a
Actually, kind of tough because I think you're thinking about doing some van for health.
Yeah.
So what our next plan is, we are going to do a van for students, like, for high school students in underserved areas that do not have access to a robot, do not have access to goggles, so, and then 3D printing. So we wanna, because, that's my lab, about 3D printing technology. So take like, for example, clay printers and, with a van, have the students come from school and kind of try to do different things. That's as far as we've gone. But the good thing about it is if the price of the VR sets drop, which everybody expects, then all you have to do is to go online and then download it and then put this on. Then you don't need anything else. Everything is in the air.
And AR and VR, is this set up solely virtual reality, or are you thinking about?
Yes, so that's a good question. The question if this is only about VR or AR. So at the beginning, we had plans to do both, but it became too complicated. But what we learned that VR is good for some particular tasks, like, you want to learn about safety. You don't want to be around the robot. You don't want to do anything. You want to learn everything about safety in here. What is the work envelope? A lot of the lessons that we are developed in here, you shouldn't be even near the robot. After this, if you're near the robot, you want to actually do 3D printing, that is where, you can do remote control of the robot and the AR. We did not go there. This has been like wrapping us in a tight knot. But that was the original idea, that we do some things with VR and then some things with AR. Okay. All right. Okay, thank you. Thank you.